In this video, we're going to talk about sets and tuples. So again, we've been talking about data structures. We've looked at lists. We've also looked at dictionaries. So sets and tuples also fall in this case. But we're going to try and look at this too because they're often misunderstood. Sets and tuples are often misunderstood. So if you've been using like lists and dictionaries, you're going to just love what these are going to do. So I'll explain to you when and why you'd use each of these two, how they work, and we'll also do some just live coding, of course, just to see how this goes. So let's get started. First, what is a tuple in Python? So a tuple is an ordered and immutable collection of items. This is a major difference between a tuple and a list. A list is mutable in that you can manipulate and change items in a list, but in a tuple you cannot. So it is ordered and it is immutable. What that means is that you cannot change a tuple after you've already created it. So we use tuples, and how we define them, we use parentheses, unlike lists where you use square brackets. But let's just go to our code editor to understand what this looks like. So I'm going to create a variable here, just define a variable, and we call this variable my tuple. And like I mentioned, in tuple, we use parentheses, not square brackets. You can have, for example, 1, 2, and 3. So those are items in our tuple. So remember, the tuple is ordered and it is immutable. Immutable means that you cannot change the items in a tuple. Let's start by just printing out this tuple. So once you do that and we run our code, you just say Python 3. I call this file sets tuples.py. Sets tuples.py. You can see it prints the tuple there. So we can try and just check the type quickly to understand what this is. So just print, and then we use, of course, the type method to check that, and we're going to wrap my tuple in here. So if you do that and run, you see it says it is a tuple. This is the type of what you've just looked at. So why do we use tuples? Like, why are they important? First, tuples are faster than lists, and tuples are also immutable. So, for example, if you are dealing with data that is fixed, this could be data such as coordinates of places, RGB values, or even ID numbers and all these sort of values that are fixed data and values that you don't want them to be changed or updated at any point. We use tuples in that case. Tuples can also be used as keys in dictionaries. This is one key element. Tuples can be used as keys in dictionaries. The difference that comes with this between this and a list is that a list can be used as a value in a dictionary. Remember, a dictionary is a set of key value pairs. So you can use a tuple as a key, but you can use a list as a value. So I do hope that makes sense. So what are some of the common tuple operations that you can do? We've seen how you can declare a tuple and initialize it. So to access values in a tuple, I'm going to I'll just write a simple print statement. We can use this one. So we'll just try to access elements in my tuple. So we use square brackets, the same way we use in a list. Then we specify an index. So if I say I want an element at index 0, I'll just do that. And you can see it prints 1. 1 is at index 0. This is one of the methods of how you can access elements. So ideally, the same way you access elements in a list is how you access elements in a tuple. The other thing is how you can slice a tuple. So how you can create a subset of a tuple, basically. So in this case, I shouldn't use the word subset, but again, let's just say how you can slice a tuple. So just like the name of the tuple, the square bracket, then you can specify the start index. For example, you want from index 1 all the way to the end. The same way you would slice a list is still the same way that you would slice a tuple. As you can see here, we've sliced it to get a tuple with only 2 and 3 as the items. So I believe this is already there. So the other thing is, how can you unpack a tuple? This is one thing that is really important. So I'll just write here. We refer to it as just tuple unpacking. So tuple unpacking is this is how it looks like. For example, I can have X for in our tuple. In this case, my tuple has 3 items, right? So it has 1, 2, and 3. How I can unpack it is I'll declare three variables and I'll declare them next to each other like this. I can have a variable called x, another one called y, another one called z. And I can assign the tuple there. So I'll just say my underscore tuple like that. This is what we call tuple and packing. So to see what this looks like, we can just print x, y, and z, x, y, and z like that. So if we run our code, you'll see it prints them separately. You can also just print even just one of them. So let's say you just want to print x. You can print x like that. And if you run your code, you see it print one. So this is what we refer to as tuple unpacking, where you take each of the value in the tuple and you assign it a variable and basically use it. So ideally, you are assigning each of the values like this. So tuple unpacking is just then I think the new concept that you're looking at this case. But every other operation, how you slice a tuple, how you access elements of values in a tuple, still the same way that you'd access elements of values in a list. So one thing that I want you to note here is that tuples with one item need a trailing comma. So when you're declaring a tuple, at some point you might have a tuple that only has one item. So I want to just call a tuple here and I'll call it one item. So this is how it looks like. You do that and then let's say the tuple only had an item. Let's say you just had like name. So you can just say name, but now you have to have a comma there. So this is something that is really important. In a tuple, I'll actually just write this as a comment here. I'll just say note uh, tuples tuples with one item need a trailing comma. So this is important to note, because remember, if you just write a tuple like that with no comma, someone might think of it as you're trying to call something, but this is how you write it. This is specifically just for tuples. Now that we understand what tuples are and why we use tuples, just as a reminder, we use tuples because they are faster than lists, they're immutable, which makes them great for fixed data, and they can also be used as keys in dictionaries. Now, let's look at sets. I'll just create another comment here and I'll call it sets. So in this case, just reduce this to one space. Okay, now let's look at sets. So sets are also an important concept to understand. What a set is an unordered, mutable, and non-duplicatable collection. So I'll just repeat on that again. A set is an unordered, mutable, and non-duplicate collection. So if you're working with that tuple, you want something that is a non-duplicate collection, a set would be the best choice for you there. We used the way we create sets is quite different as well. We use curly braces, or we also have a set constructor. So the same way, like in a dictionary, we could also use a constructor to create a dictionary. We can do that here as a set. So I'm going to declare a set. I'll just call it my set, and we use curly braces. The only difference between a set and a dictionary is that in a set you have single items like 1, 2, 3, 5, but in a dictionary you have key value pairs, but in both you use curly braces. So this is a set. In this case, we can just print my set here. So print my set, and if we run our code, you'll see the set gets printed down here. The other way that you can also just quickly check the type, just to confirm again, is type, then you pass in my set, and if you run this, you see it tells us that this is a set. So it already recognizes it. Python already recognizes this as a set. The other way that you can create a set is you can use a set constructor. So to create a set constructor, so for example, uh, I'll just call a variable and I'll call it your underscore set. So you can use set constructor. This is what we refer to as a set constructor. Then you can define the elements that you want to define for your set. So for example, I'll just say 1, 2, and 3 and 5 like this, but this will not work if I just do this. If I add curly braces like that, you can see how this changes now. And if I run our code, I'm going to try and print your set here. So just print your set. And if we run our code, you see it prints 1, 2, 1, 3, 5, like that. If we try to check the type of your set, this will tell us quickly what this does. Again, you just need to wrap it like that. Okay, we need an extra parenthesis there. If we run this, you see it already recognizes this as a set as well. So these are the different ways that you can declare or you can define a set. Why do we use sets? There are a number of reasons why you would use sets. One of the main ones is that in a set, it automatically removes duplicates. This is a major difference between a set and a list. Remember, like you mentioned when you're talking about lists, in lists, you can have duplicate values and duplicate elements. But in a set, it will automatically remove duplicates. And it is great for membership testing. So, like if you are checking if an item exists, that is great for you in a set because a set removes all duplicates. So you're only going to have unique items or unique elements. And it also supports set theory. So if you've done mathematics, especially the pure mathematics, so you've learned about sets, there's the idea of set theory. So set theory operations like union, intersection, all these set theory operations, these sets also support them. So again, sets is an entire topic in mathematics that you can go and learn on your own time if you haven't already. But this is what sets are. So I'd like us to just I'm going to add a duplicate here. For example, I'll add a duplicate like 2 and 1 maybe. Then I'll do 5 one more time. So you see all these duplicates. If we run our code and I'm going to just print your set, if we run this, you'll notice that it still only gives us 1, 2, and 5. That is because it automatically removes duplicates, which makes it perfect for things like membership testing, like you've mentioned, any case where you don't want any repetition whatsoever. So there are a number of useful methods that you can also apply when you're talking about sets. So for example, you can add an element to a set. How you'd add an element to a set, let's say we want to work with, for example, this first set here. And I'm going to just write everything here so that I don't have to rewrite everything at the same time again. So in your set, you just say the name of the set, my set. You can just say my set dot add. So you specify what you want to add and add like 4. For example, there's no 4 in our set here. So if I run the code, you'll notice that we have 1, 2, 3, 4, 5 now. 4 has been added to the set. So that is how you add an element to a set. You can also remove an element from a set. To remove an element, you'll just take the name of the set, in this case, my underscore set, and I'll specify what I want to remove. I'll use the remove method. Just say dot remove, and I can pass in, let's say I want to remove 2. If we run our code now, you'll notice that 2 has been removed, and now we have 1, 3, 4, and 5. And 4 is what we just added. There are a number of set operations that you can also do. So we've talked about this set theory operations. So there are set theory operations like union, intersection, this difference. How they work is usually have two sets. Then you want to, for example, in union, you're joining the two sets. In this case, we have this set, your set, and my set. We might want to join these sets. So like from just set theory in general. So we're going to just print everything out. We will take the first set. In this case, the first set is called my set. Then you'll just say union, not dot union. Just say my set dot union. Then you specify the second set that you want to join here. So in this case, the second set is your set. So if we do this and we run our code, you'll notice that we get a new set here that has 1, 2, 3, 4, 5. Again, remember, sets remove duplicates. So all these values that are duplicated here between the two have been removed. If I go ahead and add another something here like 9, 8 and like 7, if I do that and we run this, you'll notice that 7 and 8 has been added. Now, this also brings about one other thing that we mentioned, which is that sets are it's an unordered, mutable, and non-duplicate collection, right? But you'll notice that during our union, it ordered everything. You see 1, 2, 3, 4, 5, 7, 8. When in this part, it wasn't ordered. You'll notice even at this section still, it wasn't ordered. So just keep that in mind. The other set theory operation that you can do is intersection. So intersection is when you want to look at the elements that are different between the two sets, so that are not common, that is. So I can just say my set dot intersection, and I'll specify the second set. So in this case, it should be your set. If we do this, you'll notice that it creates a new set that has 1 and 5. So 1 and 5 are the two elements that are different between the two. You can also do the difference as well. So for example, again, we'll just do the same thing. Actually, I'll just edit one of these. Okay, let me just write it fresh. So I'll just print my set. Then we'll just say my set dot difference and your set. If we do this and you run, you notice that it gives us 3 and 4, right? So we get 3 and 4 as the difference between these two. So that is ideally what some of the set theory operations that you can do. Note that sets do not maintain order. As much as we've seen how they've sort of ordered some of the things here, they do not maintain order. So it's sort of sorted, but didn't maintain the order. And there's no indexing or slicing like in lists and tuples. So we saw in lists and tuples how you can do indexing and how you can do slicing, but in sets you cannot do that. I'll actually just write it as a comment again somewhere here. So I'll just write something like uh, there is no indexing or slicing in sets. Yeah. So actually I'll just write here something like unlike, I'll just say unlike lists and tuples, there is no indexing or slicing in sets. Take note of that. So now that you've understood how you can write sets and lists, you can also just try and write some projects around this to help you test out your understanding. And I'm going to give you one such simple challenge that you can do during your own time. And this is what the challenge is. I'll just type everything here. So I want you to create a program that takes a list of, should be a list of items. Take a program that takes a list of items with duplicates and it returns a few things. And returns, so these are the things that it has to return. One, this needs to return a tuple of the first 3 unique items. A tuple of the first 3 unique items. The second thing that it has to return is a set of all unique items. So using everything that we've learned up to this point, I'd like you to just do this simple challenge. Again, it's quite direct. You can be able to just figure it out. And in case you face a challenge, as always, let me know in the comments below. So now at this point, you know how to use both sets and tuples. And in the next video, we're going to just explore a few other concepts. But again, don't forget to like, comment, with your practice challenge solution and subscribe so that you don't miss these kinds of lessons. Also, remember that we have a Discord server right now. So if you go to the comment section below, you'll see the invite to the Discord server. Feel free to join and you'll find some of the other people that you're doing the same lesson with, the same courses. You can interact and share a few things. Okay, cheers.